Okay, so I think question 3, after looking at this one right here, says, so hey, why do you think this is called a step function? And I don't know about y'all, but that looks like a stair step. That's exactly why it's called a step function. You've got a flat piece, and then you're going to have a little bit of a rise, and you're going to have another flat piece. You're going to go up a little bit, you're going to have another flat piece. So it looks like a bunch of stair steps. So there are two special step functions that we can look at. One of them is called the greatest integer function. There's this notation, and I want to be warning you when I say this is the notation that Springboard chooses to use. There are other notations that also stand for the greatest integer function, just depending on who the publisher is. So the fact that it looks like, I don't know, a forward facing L and then a backward facing L, that's kind of what it's like. That is the notation that Springboard uses, but that's not the only notation that's out there. So just be careful if you run into a different notation. I think another one that you may run into is this kind of a double bar thing. Looks like that. So there's like 2 bars on the outside of the bracket. That's another symbol for the greatest integer function. But so anyway, here's what the greatest integer function is saying. It's saying that if you plug in any number, and notice that here we're talking about not whole numbers, but any number, and decimals are easiest to think of because fractions, sometimes to think about, to graph fractions, usually what we have to do is change them to decimals before we can graph them. So it's easiest just to think about decimals. If you want to graph all of the numbers between 2 and 3, then they're going to automatically round down to 2, to the nearest greatest integer beneath it. So what this is saying is, here's what the table looks like. Let me draw a table. This is saying plug in an x value, and then the y value is going to be the greatest integer below it. So let's say if I plug in 0, 0 is an integer, so the y value is 0. Now plug in 0.1. You plug in 0.1. That's a number between 0 and 1, so it's going to round down to 0. Plug in 0.2, it's going to round down to 0. Plug in 0.3, it's going to round down to 0. Plug in all of these numbers until you get to 0.9, and 0.9 is still going to round down to 0. But then as soon as you get to 1, the y value now is going to jump up to 1. 1.1 is going to round down to 1. 1.2 is going to round down to 1. 1.3 is going to round down to 1. All the way to 1.9. 1.9 is going to round down to 1. 2, it's going to jump up to 2. 2.1, it's going to round down to 2. 2.2, are you seeing the pattern? It's going to round down to 2. 2.3, it's going to round down to 2. And then you go all the way down until we get to 2.8. It's going to round down to 2. 2.9, it's going to round down to 2. Get up to 3, it jumps back up to 3. Okay, so 0, 0, all over to 1, it stays down at 0. But then as soon as we hit 1, it's going to jump up to 1. And then 1 point everything all the way until it gets to 2, it's going to stay 1. 1.1 stayed 1, 1.2 stayed 1, 1.3 stayed 1. Everything all the way up to 1.9 stays 1. But as soon as you hit 2, it jumps up to 2. All of the numbers between 2 and 3 are going to stay down here at 2. The y values are going to stay 2 until you get to 3, and then the y values jump up to 3. So this is what the greatest integer function looks like. Okay. Now, when you go back negative, it kind of seems like it works backwards, but it's because people have a hard time rounding down. So if this is, let's say, like we just did right here, at 0, we were rounding to 0, but as soon as we go to negative 0.1, we round down to negative 1. Negative 0.2, we round down to negative 1. Negative 0.3, we round down to negative 1. So that's still rounding down. All the way until we get to negative 0.9, that still rounds down to 1. But as soon as we get to negative 1, when we get down to negative 1, it stays negative 1, but when we get to negative 1.1, it rounds down to negative 2. And then negative 1.2 rounds down to negative 2, and so forth. So just remember that on the greatest integer function, that it's shaded on the left and it's open on the right. And it's that way all the way across. Okay. This is an interesting graph because if I ask you what the domain of this is, so many people don't know how to answer the domain, but the domain is actually all real numbers because it's very hard to put an arrow on this. It is going on forever in as far left and as far right as you can go. And there's no values where the x value is undefined. There's always a place to round. So the domain is all real numbers. The range is a different story. The range is not, it's a set of numbers. You can't list them all, but there's no decimals in between. So you would have to say, you know, all the integers. You wouldn't be able to say all real numbers because we don't have any decimals in the range, but you could say all integer values, not all real numbers, but all integers. So that's what the step function looks like. Now, Desmos will do that, but it's kind of weird. It is, let me clear all of this off. I should have just opened a new screen because I think I wanted to do something with that anyway. But there is this button over here. If you press the function button and you go over to miscellaneous, there's two things that you find over here that will work for this greatest integer. And it's the word ceil, C-E-I-L, that's short for ceiling, and floor. This is, and the greatest integer function that we just did, we were doing the floor. And the reason we call it the floor is because every time we rounded down, right? So 0.1 rounded down to 0, 0.2 rounded down to 0, 0.9 rounded down to 0. At 1, we jumped up to 1, but 1.1 we rounded down. So since we were rounding down every time, that's called the floor function. And so for Desmos over here, you can click that thing, but all it's going to do is put floor in there, and then you just put in the x value. Now, it gives you these steps. It shows you all of the steps, but again, what it does not do, it does not clearly define for you which end is open and which end is closed. So it literally takes you scrolling over to see what happens. So you see 1.95, 1.97, 1.99, and then it jumps up to 2. And it shows you right there, it's filled in at 2. And so that's where you have to go to, you just have to go and find out where, how it's rounding. So which end is open. So 1, 1 is filled in, but the next one, 2, 0, or 2, 2 is not filled in until you get up there. So we know that it's going to be closed on this end, opened on this end. Now, the other way, which I think is what they talk about in, I'm going to turn that off for a second. Oh, I didn't mean to close it, but that's okay. The other greatest integer function, it may not be called the greatest integer function, it may be called something else. It is, we get to it by doing the ceiling. And I do the ceiling of x. And then some of you may be thinking, hey, that looks like it's exactly the same thing. It's not exactly, because if I put the other one back up, you'll see it's very close, but it's not the same thing. So the purple one is the ceiling function, the black one is the floor function. So it's a little bit of a shift. I'm going to turn that one off. That's what I meant to do a while ago. And you'll see what's happening here is now this time we're doing what to the x values? We're rounding them up to the next highest integer. So for the 0.5, for the 0.6, for the 0.7, for the 0.8, for the 0.9, all of those are rounding up to 1. And anything between 0 and 1 is rounding up to 1. So it's not rounding up. It's not rounding down like the floor function was. It's rounding up. So that's the difference in those two functions. I think Springboard shows you that function over here when it talks about it in right here. A step function known as the ceiling function is written like this. So this is the notation that they're using for the ceiling function, where they put the little L's are at the top. So that's the ceiling and the floor function.